Now I leave you with a little more complicated example, which is also in the reading. The integral from 0 to 1 of natural log of x dx. If you notice, and have been paying attention to the other examples, you would notice that we have a problem as x gets closer to 0. The natural log function has a vertical asymptote at x is equal to 0. And so we need to evaluate this just like we did the previous problems. The limit as a goes to 0 from the right of the integral from a to 1 of natural log of x dx. And in our little dream world, we remember that the integral of natural log of x dx is x times natural log of x minus x plus c, which will help us when we want to find the antiderivative here. We do the limit as a goes to 0 from the right of x natural log of x minus x from a to 1. Plugging in, we see that we get the limit as a goes to 0 from the right of natural log of 1 minus 1. Both of those are pretty simple to evaluate. Minus a times natural log of a minus a. And the a part will be simple to evaluate. The question is, what is the limit as a goes to 0 from the right of a natural log of a? In fact, this is indeterminate form. And it's indeterminate form because we have a form of 0 times negative infinity. So, with indeterminate form, we need to use L'Hopital's rule. So let's take a look at what that limit is. Limit as a goes to 0 from the right of a natural log of a. One trick that we can use when we have 0 times infinity as our indeterminate form is flip one of the functions we're dealing with into the denominator. In this case, we're going to flip it so that we get natural log of a over a to the negative 1. I'll let you prove to yourself why that's the same thing. L'Hopital's rule can be applied because we in fact do have two differentiable functions and have an indeterminate form. So when we evaluate, we get the derivative of natural log of a as 1 over a. Derivative of a to the negative 1 as negative 1 over a squared. When we evaluate this limit, the limit as a goes to 0 from the right, and clean it up a little bit, we get the limit as a goes to 0 from the right of negative a, which is just 0. So the trick here was figuring out that we needed to put the a to the negative 1 in the denominator, which, by the way, is the same as dividing by 1 over a, which is why we would get back to a. So the overall answer is the limit as a goes to 0 from the right of natural log of 1 minus 1 minus limit as a goes to 0 from the right of a natural log of a minus a. These parts are both 0. Natural log of 1 is 0. The only thing that's left is the negative 1, so our answer is negative 1.